Okay. So the only example we've got left is example 12 from Unit 10. So what we're going to do is we're going to start off by thinking, not about example 12 itself, but we're going to think about what happens when an object sits on a table. So if you've got a table here, and you've got our object on top of it, then we can think of them individually about the forces that they have acting on them. So if we think about object A, object A has obviously got the weight, its weight pulling it down, so this will be mg, where m is the mass, and that balances to stop it falling down with a force that we call the reaction force from the table. So I'm going to call that x in this case. And those two, x and mg, must be balanced, right? Because it stops A falling through the table. On the other hand, the table itself, right, will have a reaction with the floor, but if the table is supplying a force of x onto A, the only way for that to be happening is if the table is feeling this same x force from A. And in this case, yes, it will just be the weight of object A on the table. That's quite intuitive, and the key thing is that the two x's are balanced. So whatever force the object A is having acting on it from the table is the force that the table feels from A. That will always be true. Those two forces will always be the same. For the A to feel x, the table has to feel x as well. So when we go and look at an example with a lift, or in this case a scale pan, but a scale pan is essentially a lift, what happens is that we've got to consider all of the objects individually, and they will only feel forces on them from other things that are touching them. So let's have a look at our lift. It tells us that it's going upwards at an acceleration of 0.5 meters per second. So that's going to be our positive direction up, and it tells us it's being raised by a string here which will have a tension T. And there's two things we can do in these questions, right? There's three different objects, there's the lift and there's two blocks. And the first thing we can do is we can treat it as one object. So imagine that it's one whole object, and then we can resolve it in the upwards direction. So if it's one whole object, the force is just T. T is the only thing pulling this lift up. And that's being put off by the weight. And the weight of this object, what it tells us, the lift itself is light, but these two objects are 400 and 600 grams, so we add them together, that's 1 kilogram, so that's minus g. So that's the weight coming down here, which is 1 kilogram times g, so it's g. So that's my force. And if it's accelerating at 0.5 upwards, I've got to have that t minus g is 0.5 times the mass, which is 1. Okay, so mass is 1 and the acceleration is 0.5. So then I rearrange and we get that T is equal to 10.3 newtons, taking G to be 9.8. And that's part A, that's the simple part. For part B, it asks us to find the force exerted on mass A on mass B by mass A. So that's where we've got to consider the reaction forces. So I'm going to draw each object separately and we're going to think about them individually. So the first object I'm going to draw is this object A. And this object A has a weight of 0.4 g pulling it down, and it has a force that I'm going to call X, which is coming from B. So because A is resting on top of B, it's B that's actually in contact with A. A doesn't experience any forces directly from the tension or from the lift itself. It just experiences this force of X from A. Below that is B. So B has its weight pulling down, which is 0.6 g. It has the force of X, because it has to balance with that force that A is feeling, so those two forces are equal, and that's the force of the feeling of A being on top of B. And on top of that, it's going to have another force, which I'm going to call Y, and that Y is coming from the lift floor. So the lift floor here is exerting a force of y, because otherwise this 600G would just fall straight through the bottom of the lift. Right, so they're all of my forces, and we've got to remember within this that the acceleration for all of them is 0.5 meters per second squared. If the whole lift is moving up at that speed, then each of them individually must be. So all we're going to do is we're going to resolve them individually. So for object A, we've got the force. Remember, the positive direction is up, right? So for object A, force is x minus 0.4g, and we have, when we do F equals ma, we have x minus 0.4g equals, and it's 0.4 is the m, and the acceleration is 0.5. So that tells us the value of x if we rearrange it, and we pop it into our calculator. This is 4.12 newtons. And what does that x represent? This is what it's talking about in part B, which is the force exerted on mass B by mass A. It's the force between the two of them. Right, they're both experiencing 4.12 but in opposite directions from each other. So that's your part answer to part B. And then finally for part C, we look at the other object and we resolve the other object. So in B, it has two forces pushing it down. One is x, right, and the other is 0.6g. They're put off, they're stopped them going down. So I've done this wrong way around. So it's positive is going up, isn't it? So the force going up is y, and it's pulled back by minus 0.6g and minus x. They're the two downward forces, right, and y is the upward force. So then again, when I do F equals ma on this, we have that y minus 0.6g minus x equals 0.6 times 0.5, and we have that we know the value of x. X is 4.12 from earlier. So this is y is 4.12 plus 0.6g plus 0.6 times 0.5. Add them all together. Which is 10.3 newtons. So y is experiencing a force of 10.3 newtons, and that is the force that is coming from the scale pan itself. So the answer to part C is there for you. It's 10.3. Right? So it's all about these questions considering each of them individually. Right? You can do it once to treat it as one whole object and add their masses together. But for the individual parts, when you want to find the force exerted by one object on another, you always must balance out the force going both ways is the same. And the forces you'll only be affected by are objects touching you. You are not affected by a force that is not absolutely touching your object. Right? So that's why A only has two forces. It's got its own weight and it's got the object touching it. B has got three forces, its own weight, and the force from A on top of it, and the force from the lift which it's touching. It's sat on the lift, so the force of the lift pulling it up. It is quite tricky, this one. And actually we're not going to use any questions from the exercises. You're going to use the extra worksheet, and I will attach that to this lesson when I send it out. So it's the extra worksheet, it's got all the solutions to it at the end. Have a go, particularly difficult, tricky concept, but hopefully you've understood how to do those questions.